today what we're going to do is we're going to continue with chapter 2. Again, 2A, 2B, 2C. We're going on to 2C, so we've had a quiz on 2A, 2B, and we're going to move on to that next skill. So we're going to review a little bit of our algebra, and if you remember this, you learned this in 7th and 8th grade. You might have seen some of it in 9th grade, and we're just going to review a little bit. So first of all, we're going to look at the addition property, and it says if I have A equals B, if I add C to both sides, then it's addition. Okay, so for example, you're going to see right here, I've got 3 equals 3. Notice that I add a 2 to each side, and it's called the addition property. Duh, right? Okay. Let's go on and move to the subtraction. It says that if I have A equals B, then if I subtract C from each side, it's subtraction. So an example would be I got 3 equals 3. Notice I'm subtracting a 2 from each side. What did I do? I subtracted. We'll do examples, so it'll make more sense as we do it. I'm just going over the properties. Okay, the multiplication property, what that says is that if I have A equals A, if I multiply something on one side, then I multiply it to the other. So an example would be 3 equals 3. I multiply by 2, multiply by 2. It's the multiplication property. And then finally, division property. If A equals B, if I divide both sides by C, it's division. Or 3 equals 3, divide by 2, it's division. Okay, so those are the basic ones. It's like, you know, when we're solving a problem, I'm like, okay, what do we do next? And you're like, I add or I subtract. You know how we had that verbiage and we kept talking about it? That's that. Okay, so you've done it before, it's just talking about it. All right, then there's the substitution property. If it says A equals B, then B can replace A in any expression, and we'll talk about that more as we do it. If you did substitution before, it's taking something out and putting something in for it. And then the distributive property, and of course you've done this before. It's I have a friend. A is going to give candy to B, then A better give candy to C. Okay, with plus sign in between. And you've seen it before, so it shouldn't be that big a deal. All right, let's go see these and how these properties of congruence. So if you remember again in 7th and 8th grade, we talked about the reflexive property. What that is if I have AB, a line segment on one side, I have AB, line segment on the other side. It's reflection. It's kind of like a reflection, I call it, except, you know, a true reflection would be flipped, but this isn't flipped. So if I think about it, I think about this as kind of being a mirror, okay, and it's reflection. It's identical on the other side, all right? The symmetric property, what it says is if line segment AB is congruent to line segment CD, then CD is congruent to AB. Essentially what you're doing is you're doing the switch. Or you could think of it as the flip-flop. All they do is the left side and the right side flip. Or switch. If you think symmetric switch, that might help. Okay. And then the transitive, kids get confused between substitution and transitive. I think of transitive more with words and symbols, with like congruence. So an example is if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. And essentially it's kind of like the law of syllogism, but with symbols. Okay, so notice this is the inside of the Oreo cookie. I take those out and I put the two ends together. Okay, if angle AB is congruent, if angle A is congruent to angle B and B is congruent to C, then A is congruent to C. So here's the dark part of my Oreo cookie. I'll make this pink. This is the inside of my Oreo cookie. Take out that, and then I put the two ends together. So A is congruent to C. So again, it's kind of like law of syllogism. It's just not with words. It's with symbols. So if you think again of the Oreo cookie, that might help. Again, with symbols, not with words. Okay. All right, so this is like the law of syllogism again, but with not with words. So let's take a look at this example. If I look at this example, what law would this be? Yes. very good. It's reflexive. Now, I'm going to tell you that in your homework, if you check your answers with the book, they'll say reflexive property of blah, 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 blah. All I need is reflexive, short and sweet. Okay? You don't need property, blah, 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 all that other stuff. Just reflexive. Okay? Next one. If 2x minus 8 equals 10, then 2x equals 18. What did you do to get that answer? Think algebra. You did what? Added 8, right? So all you need to do is go addition. And you're done. Again, they'll say addition property. Don't put property. You don't need to because you write property on everything. Don't need to. All right, next one. If 4x equals 16, then x equals 4. What did we do? Division or divide. I don't care what you use. They're both the same. I'm going to go division. Again, you can put divide. I don't care. Again, don't need property. Here's the next one. If line segment XY is congruent to line segment TW, and line segment TW is congruent to line segment LM, then line segment XY is congruent to line segment LM. What is it? It's transitive, yep. And again, it's kind of like the Oreo cookie. Here's the, oops, thought I had my highlighter. Here's the hard cookie shell. Here's the hard black cookie shell. Here's the inside double stuff. Take the double stuff off, put the two ends together, and here's my outside of my Oreo cookie. Put it together and dip it in your mouth. Okay? So it's the transitive. You don't say property of blah, 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 blah. Questions on those? All right. This one asks you to solve and explain each step as you solve. So what I'm going to do is I'm going to kind of get you into the habit of doing two-column proofs. We're going to do more later, but I'm just going to go ahead and start you guys on it. So on these problems, what you do is you make a line like this, a vertical line, and up here you're going to make, up here you're going to make a horizontal line. And up here I'm going to put statement. And here I'm going to put reason. Okay, step 1 is the problem. And so the reason behind that is given. All of the statements when you first start out are given. Because without it, you can't do it. All right? Now, let's go ahead and let's solve this problem. So what would be the next step when we solve this problem? Yes? I'm going to add 10. So the next step on this side, and you're going to number these. It's really important to number them. All right, so I'm going to go 5x equals negative 40 plus 10 is negative 30. And the reason is going to be addition or add. Now, do you remember last chapter when I'm like, okay, what do we do to solve this? Okay, what do we do to solve this? You know how I kind of guided you through it? The reason why I did that is because I knew that this was coming. Okay, so it should be easier. I'm going to solve this next one then. What do I do to solve this? Divide by 5. So x equals negative 6, and this is divide or division. Done. You just did your first proof. They get harder. This is very easy. Okay, they get a lot harder in chapter 4, but this is kind of the surface. All right. Let's move on. Here's the next problem. Again, it goes like this. A lot of times they put an S on the top and an R at the top, which is statement and reason. Again, this is problem 2, but it's step 1. Okay, what would be our reason on this again? Given. It's always given. Okay. So the second step then, what would I do on this problem? What could I do?
Add 3x.
Sure, I can add 3x. Now someone else might say, I don't think we should add 3x. I think we should subtract 9. You're both right. You can do whichever one you want right now. Okay, so you mentioned add 3x. So I get 7x plus 9 equals 16, and it's add or addition. Do only one thing at a time. Don't like add and subtract and write addition and subtraction on the same line. It's one step at a time with the proof. Okay, so then number 3, I'm going to subtract my 9. So 7x gives me 7. My reason is subtraction. Or subtract. I'm fine with either. And then finally, number 4, I'm going to divide. Yeah, so x equals 1. 4 is division or divide. I don't care which one you do. Any questions? All right. This is why you take algebra before geometry. One of the many reasons. Okay. And you can see too, if you struggled with algebra, this becomes difficult. All right. This problem. This one's a little bit different, but I think you'll be able to handle it. Again, statement, reason, step 1. Reason 1 would be given. Now, students sometimes struggle with this, so I'm going to highlight the y, and we're going to peel this like an onion. I want y by itself, so I'm going to leave y by itself. I'm not going to touch y, but I got to start peeling stuff off. So what would be the next step? Yes? Subtract 5x. So I get 3y equals, now, where do I put the subtract 5x? Should I put it before 25 or after 25? Okay, you would think, truthfully, it doesn't matter, but if we really think about algebra, where did we put that? We put it before. And why? Why would we put negative 5x plus 25? Why would we put it in that rather than 25 minus 5x? Do you remember? Okay, we'll hold off on it and see if you remember. So this was subtract or subtraction. All right, number 3, now what do I do? Again, I'm going to get that y by itself. I'm not going to touch y. What am I going to do? Divide by 3. So y equals, what do I get? Okay, if you need to, you can come down here and do some chicken scratch because you can't do it in the problem. 3y equals negative 5x plus 25. If you remember from last year, divide by 3, divide by 3. Y equals what? My kids, you should know this like the back of your hand because we did it over and over and over and over and over and over and over again. What do we get? The 3 is underneath the negative 5. What do we do? Do I divide it? Should I put negative, what is that? Negative 1.6 repeating? Should I do that? Okay, I got to know. Why no?
Put negative 5 over 3.
We do. Why is that? Why would I write this as negative 5 over 3x? Why wouldn't I put it as negative 1.6 repeating? Yes?
So the calculator can't do that?
It can. Good guess, but it can. Let's keep going and let's see if it comes more apparent to you. So now I've got 25 and I got 3 underneath it. What does that become? What does it become? 25 over 3. What do I get? 8.3 repeating. So plus 8.3 repeating. Or you could write it as y equals negative 5/3 x plus 8 and 1/3. Now, if you're going to do the 0.3, you got to get the bar over the top unless it asks you to round. Okay? I'm going to go back up in my problem and I'm going to write down the correct answer. So 5/3 x plus 8 1/3. This, of course, is division. Now, let's have a discussion a little bit. Why would I leave the number in front of the x as a fraction, an improper fraction, and go ahead and take that other number and divide it out. Where do we use something like this? Yes.
For slope.
For slope.
Y equals mx plus b.
Winner, winner, chicken dinner, right? If you remember from last year, oh, yeah. Y equals mx plus b, right? Did you learn this last year? Yeah. You'd be like, we did it so much. Yeah. Slope, remember, is your m. It's your rise over your run, always. If you take that number and you put it in a decimal, I will count it wrong. Slope is rise over run. It is not a decimal. So you must do it rise over run. Otherwise, you can't graph it. Okay? This is your y-intercept. You work that out because if you remember with graphing, you start with your b first. You put it on the y-axis and then you move it up and down and over to the right. Do you remember that? Yeah. So you did a lot of it last year. I assume you know how to do it, and I expect it a certain way. So that slope is never, ever, ever a decimal. M is never a decimal. It's always going to be your rise over run. It's never a mixed number. It's always your rise over run. That's the definition of slope. Your b can be a decimal. It can be a fraction because that's where it lies on the y-axis. And I know that it's a proof, and I know we're not graphing, but that is something that is so important that you learned in algebra that I make sure that you remember that. Why? Because you're going to be graphing in here. You're also going to be graphing in Algebra 2. So I don't want you to go back to really bad habits. I want you to keep those good habits from last year. Right? Any questions? Now, if you still struggle with y equals mx plus b from last year, you might want to come in so that we can do some sample problems with you. Okay? Let's go ahead and let's take a look at the book and your assignments then.